Good evening and welcome to this meetup this evening with the name of Explainable AI and DevOps and MLOps for banking. I'm Ivan Luciano Danesi from Group Data and Intelligence Office of Unicredit, and I'm pleased to present this event that has been powered by Data Science Milan Meetup from Data Science Community of Unicredit and the Unicredit University Digital of Unicredit. The agenda for today see two very interesting talks about the first explainable AI and the second about DevOps and MLOps, as was clear by the name of the event. But before to start with the two talks of today, I will ask to Paolo Testa to join me on stage and to say a couple of words about Data Science Milan community that helps us today to organize the event.
Thank you so much. Hello, everybody, and thank you for joining this Data Science Milan event. So just for those of you who participate for the first time to this kind of meetups, we organize Tech Talk. We were founded in February 2016, so we are 7 years old. And we are more than 2,000 data practitioners. So we organize once a month data talks. So the format of our talks is Tech Talk and then a networking aperitivo. And we have so the aim of this event is, of course, to share knowledge about the data science world, to understand what does it mean to apply data science in an enterprise level and so on. And all of this is possible thanks to our Data Science Milan staff. So many of them are present here tonight. So if you want to organize an event, please chat with us, reach us, and we can organize in your startup or organization a Data Science Milan event. Just a very quick information about our channels. So if you want to see one of our 70+ meetups, you can find us on YouTube, on our YouTube channels and on SlideShare. After this event, we are going to public in our Medium blog a summary of this event. And of course, if you want to join the community, you can sign up in our Meetup and Eventbrite channel or on our LinkedIn Meetup, so then you will be updated on the next events. And I think that's all for this. So if you want to organize the next Data Science Milan talk, just talk with us, with staff organizers, or write an email to datasciencemilan@gmail.com. And that's all for me. So enjoy the event, and thank you so much, Unicredit, for helping organize this event. Thank you, Ivan.
Thank you. Then, okay, before to introduce the next, the first speaker of today, I will ask to the one here and the one connected via the streaming that is now also on YouTube to scan this QR code and to go to the app Slido and to insert the code of the event, so you can also make your questions. That we will collect the questions during all of the two speeches, and then we will manage the Q&A session at the end of the two talks. Then a couple of seconds more to allow you to take notes about this. One more, and that's all. It's now the time for introducing Ilaria Bordino that will talk about explainable AI in the banking industry. Just an additional information about this study and this research that is conducted within the Rome Technopole innovation ecosystem. Then, Ilaria.
Hi everybody, and thank you for having me. So we are going to talk about explainable AI in banking. Here you can see a very quick agenda of what we will talk about. So we will review the concepts of human-centric AI and explainable AI. We will briefly overview the state of the art about explainability in machine learning. We will say a few words about some popular methods such as SLIME and SHAP, and then we will talk about counterfactual explanations. And finally, we'll see an application to a real use case, which is customer churn. Okay, let's start. Human-centric AI, what is it? It is a very popular discipline that attracts a lot of interest nowadays, a lot of research efforts, aimed at creating AI systems that amplify and improve the capabilities of humans rather than displacing them. So the focus is all on building not intelligent systems, but systems that make the humans more intelligent. The focus is to augment the human capability to take good actions and decisions. In order to do so, AI systems must incorporate ethical principles such as explicability, justice, transparency, fairness, and privacy that are needed to guarantee that the systems that are built are actually beneficent towards the end users. Okay, you may ask, well, where do we stand? Are current AI systems doing this? Certainly, we can say that the great increase in data availability and also computational power that has characterized the last decades has greatly helped AI systems to improve their performance and provide us with better decisions, more accurate, more informed. However, there are still a lot of challenges, important challenges that AI has to face and solve properly. For example, the presence of bias and discrimination in its results, or the poor explainability of many methods, or the occurrence of privacy leaks. Solving these challenges is extremely important because you can all imagine that there are so many real-world applications and scenarios like justice, finance, healthcare, where decision makers could really take great help from the support of AI systems. But in order to do so, we first need to establish a proper level of trust towards these systems. We need to see and believe that they behave correctly. So we need to solve these challenges. One of the most important such challenges is that of explaining the behavior of this system, which has given rise to the field of explainable AI. We need to be able to explain machine learning models because many of these models that are learned from data are often black boxes to the end users, either because the model is proprietary or because it is too complex for human interpretability. Of course, there are simple models such as linear models or a decision tree that are interpretable, and we'll see that they play a role in explainable AI because they are used to explain more complex models. Here you can see very quickly a taxonomy about the state of the art on explainable AI. Essentially, there are two main classes of methods, white box methods or transparent by design or intrinsic explainability. This means that from the very beginning, you build a global transparent model that takes explainability into account. Here, the idea is that the model itself must be the explanation. And then there are black box or post-hoc explainability models. In this case, you have a very efficient black box model. You want to keep it, and you try to build a second model that explains the behavior of the black box. This can be done, again, globally, so for any input, and this is, of course, quite difficult, or locally. It means that you focus on a single instance, and you try to explain the behavior of the black box on that prediction. Black box models can also be distinguished into model-specific or model-agnostic, depending on the fact that they may incorporate or not use at all some knowledge about the internal of the black box. We will mostly see in this talk local model-agnostic explanations for black box models. There are many different types of explanations that have been proposed in the literature for different types of data, tabular, images, or text. Here I'm just showing you some examples. An explanation can be a set of rules, can be feature importance, can be a set of examples from the training set that are similar to the instance that I want to explain, or it can be a set of counter-examples, as we will see later in the talk. Okay, just I'm sure that many of you already know Lime and SHAP, but we will just say a few words to give a little context to everybody. So Lime it was the first work to propose the concept of local explanation. So the idea here is that we try to reconstruct and approximate well the behavior of the black box model in the locality of the instance that we want to explain. So how do we do this? Basically, we sample a sufficient number of neighbors of our instance that we want to explain. This can be done with various sample strategies. Lime does it with a random sampling, weighted by a proximity measure. And then you query the black box to get the labels of these neighbors that you have sampled. And then with this set of input-output pairs, you train a transparent model that you will use as explainer. In this case, it is a linear model. So the explanation will be given by the coefficient of this linear model. You probably also all know SHAP. SHAP is another very popular measure of feature importance. It is based on the concept of Shapley values, which basically compute the importance of each feature by comparing the effect of including or excluding it on all possible feature subset. The computation, the exact computation of SHAP may be challenging, but there are many known strategies to approximate it. Some are model agnostic and some are model specific. It is important to remember that the SHAP values satisfy three very important properties that are local accuracy, missingness, and consistencies. This can be proved with results from cooperative game theory. Local accuracy means that the explanation is locally accurate with respect to the outcome of the original model, and consistency means that the SHAP values are also consistent with respect to changes in the model that increase or decrease the impact of a feature. And missingness obviously means that missing values must have no impact. Okay. I'm sure that many of you know Lime and SHAP, but how many have heard about counterfactual explanations? Okay, good. Okay, counterfactual explanations is a more recent idea, which is very nice. Basically, it is based on the concept of giving the explanation in the form of counterexamples. So basically, instead of explaining which are the features that most impacted on obtaining a certain outcome, given a certain instance that I want to explain, we will return some instances, one or more, that are close as possible to the original instance, but have some feature changes in a way that the classifier predicts the opposite outcome. So the idea is to describe what should be changed in your instance to reverse the outcome of the classifier. There are many, many properties that counterfactual explanations could or should satisfy. Researchers have proposed many interesting properties. They should be for sure minimal, meaning that they should be either the closest to the input instance or changing as few features as possible. They must be valid in the sense that they must have result in the opposite outcome. They must be actionable. It means that they should suggest changes that can be done. I cannot change my age. Let's say that most likely I cannot change my race, for example, or gender. Okay, and they should incorporate, take into account the causal relations between the features. And so there are so many things, and I can tell you that the research is very active on this field, but still there is a lot to be done because basically it's very difficult, as you can imagine, to take all of these concepts together into account. Okay, I remind you to a good survey about the state of the art of counterfactual explanations, and here I have also listed for you some libraries that are publicly available and provide implementations of some counterfactual explanation methods that can be tried quite easily. In the experiment that I'll show you today, we will use DICE, and specifically a model-agnostic version of DICE that basically samples some instances close by to the instance to be predicted with a random or genetic search, and then optimizes a loss based mostly on proximity, but then you can also try to incorporate additional constraints. Okay, so in the experiment I'm going to show you, we will try these explainability methods on a real-world problem, which is the problem of customer churn. So basically, we are interested, of course, as you can imagine, in detecting early the customers who are going to leave the bank, right? Because we're going to kind of call them back before they leave the bank by maybe suggesting some possible actions or proposing something interesting. So for us, for our model, a customer is labeled as a churner if basically a level of activity within the bank and the bank products, so the number or amount of transactions, investment, activity on our products falls below a minimum threshold after a period of observation. We have, of course, an internal binary classification model for this problem that is essentially a random forest. And here I have reported some of the features that we use. We have a lot of features, and let's say that we have many different aggregations about the activity of our users on these products and features from all their movements, basically, on our data. Okay, the data set that you will see is actually a synthetic data set to enable data sharing. Sorry, guys. But we generated a synthetic data set starting from our true data. And the good news is that this data set seems to mimic quite well our true data, according to SDmetrics, which is a nice library for evaluation of synthetic data set. And this data set, which we generated with a variational autoencoder method, consisted of some 100K instances with 13K churning. We trained a random forest on it with 1,000 trees, and we have a good out-of-test performance on this model. Now, what we're going to see is that we applied SHAP, LIME, and the counterfactual explanations on this data set. So first, just if you're curious, I'm going to show you a SHAP plot that summarizes the importance of the features on all the instances in the test set. Okay, I assume that most of you can read this plot, but maybe I will just say a few words about it. So basically, you have a line for each feature. It shows the top 20 features and then summarizes the other ones. And basically, in each line, there is a dot for each instance that has to be explained. And the X value for the dot is the SHAP value of the feature on that specific instance, while the color codes the original value of the feature. So something that can be nice to see here is that basically from this plot, you can see that users who are more likely to churn when they are young probably because they are, more financially unstable, or when they have, in general, a low level of activity on all these features that represent our, wealth of movements and investments, etc. And also that second feature, when they have, when most of their transaction is outgoing, so it's pay. They are way more paying than what they are receiving. Okay, that was a summary for all the test set. Now I'm going to show you some examples specific. I picked some samples of instances that either non-charn or charn. So this, for example, is a user non-charning, okay? So a user that probably has a good, decent level of activity over the time of observation. You can see the explanation by Lime, by Shap, and then the counterfactual explanation returned by Dice. Okay, first let me say that as you could imagine, there is quite a good agreement between Lime and Shap, like so Shap, Lime was computed asking for 10 features, and 6 out of 10 here also appear among the top 10 found by Shap. Now, in the line plot, basically you see the features ranked by their weight, the explanation from the linear model, so how much they affect the prediction. The blue ones are the ones pushing towards the negative prediction. The orange ones, they push towards the positive, so the charning class. In this case, the model is almost certain that the user is non-charning, even though, look, like the first feature is actually pushing towards charning, because the first feature tells us that in the last month the user has done only outgoing transaction payments. However, there are the other features that represent activity on different products, on investments, for example, and total financial assets, that have a very high value compared to other instances that we will say, and in fact they are pushing towards predicting the negative class. Okay, it's interesting to see the counterfactual explanation. What Dice returns is an instance starting from the input instances in which the values of some features are changed, and are changed in such a way that the model predicts a positive outcome, a different outcome. In this case, predicts that the user will charn. And basically, what you can see is that it has picked some features that describe, again, a wealth of activity on our financial assets, and those are changed from low activity. And then this is also the deviation of another one of these features, probably indicating that high variability is not desired. Here you have a user that charns, for example, and here it is very interesting to see that all the line features push towards the positive class. The user will charn, and the one who has the biggest impact is the customer is a student. So a student is probably likely to abandon us, again, probably because he's not enough financially stable. And then look at the counterfactual. The counterfactual is produces an instances with some feature changed, and what it does is that it changes some features, again, mostly represent an increased activity on our financial assets and different investment products, so that the user will not charn. Okay, so what do you think of these counterfactual explanations? Did you like it? We actually like them a lot, and we think that they could be the core ingredient of new tools in bank, because with this strong focus on the actionability, on suggesting what I could change to obtain a different outcome, they could be used either to explain the outcome of automated decision systems to the end users, or, like in this case of charn, they could be employed by our relation manager to, suggest different strategies and different products to our customers. So we are definitely going to look more into that. Okay, that's all.
Thanks, Ilaria. Actually, I like a lot this topic of the counterfactual interpretability, and I actually think that the way people are able to understand the way machine thinks will also speed up the creation of a world when people can perceive the artificial intelligence as trustworthy, and will help us in having a better usage and a better diffusion of this topic that actually is also the topic where we all, the present here, also probably the connected, are working actually at the moment. Well, another moment now for the ones of you that want to ask some questions on the Slido. Then here, another couple of seconds for you to scan the QR code or take notes about the number. 1 second more, okay. And now is the timer for calling on the stage Bhaskar Chakraborty that will talk about the second speech about application on DevOps and MLOps in digital automation.
Thank you, Ivan. And thanks everyone for joining this meetup. So today's talk that I'm going to explain you about the application of DevOps and MLOps in digital automation. And the talk outlines the following agenda or the topics that to start with, I will explain the concept of digital automation and also the role of ML application development that comes into this digital automation. And then I quickly explain the challenges in the development of these the ML applications, because that intend to cover a large variety of banking workflows. And then I quickly explain, subsequently I explain the role of DevOps and MLOps to tackle these challenges. And of course, at the conclusion, I will take some concluding remarks that how DevOps and MLOps are helping in the digital automation in a nutshell. So let's talk about the digital automation in banking. So being the fundamental financial institution, the banks applies several different internal workflows to cater a large number of services to a big population, including foreign customers. And in these workflows, we basically, the human operators, they actually read the unstructured documents and they extract several different information and they lead to specific set of actions. So for example, if you want to pay someone in a foreign country, the interesting information could be your IBAN, the beneficiary, the amount, and then the action could be that the accept or reject the payment, right? Now the digital automation aims at automatizing or industrializing some of the steps in this workflow by introducing the algorithms, right? So let's take a closer look at a particular use case, that is garnishment use case, where in the workflow we can see that the human operator must read the unstructured document, and then it classifies the document to a predefined set, and then it extracts the debtor names, creditor names, hearing date, amount, this type of information, and then it leads to some specific action like account freezing or direct debits or send a notice, these kind of things. So now, having understood this workflow, we readily see that there is a possibility to apply algorithms, right? So where? The algorithms could be to extract the text from the scanned document. That could be one area. Then another area could be the document categorization and also those information extraction that we call the entity identification. And we also can see that in these areas, we can probably apply the machine learning models. And that is basically the purpose of the digital automation in banking. So having identified this scenario, we can readily come up with a machine learning application with the following basically services, right, in a microservice architecture paradigm. So these services could be the data fetcher, then optical character recognition to extract the text from the scanned document, and then send that text to document classifier, and then the entity detector, and then we need to prepare the result, right, for the internal banking application, and then again the result sender could send that information to the banking application, right? And we can also put some conceptual layers in these services, like data layer, extraction layer, machine learning layer, and transformation layer. Now, if we zoom out, then we see that how, by introducing several use cases, you end up in increasing these services in the conceptual layers, right? Why? Because you have a different nature of the problem, because you have different data, you have different business requirement. Also, your perimeter of the problem is different because you may deal with German data, Italian data, so the language could be different. Also, there could be compliance issue, there could be data protection issue. So in this, that's why you end up in increasing the services in the conceptual layers. Now we can raise a key question that how challenging is to maintain and develop all these services, right? Now, to understand this, we need to understand the life cycle of a service. So let's take a look. So let's take like a generics, like a data fetcher, right? So when we want to build this service, we basically write a bunch of code. And then this code is containerized. What does it mean? So it wraps around a bare minimum OS kernel. Why do we do that? Because with that container, we can easily put it to a production or a development or a QA infrastructure, right? And then in the next stage, as we said, that this container is being taken and put it to development QA and production environment, like basically the phase we are, right? So now, so here we kind of have an oversimplified explanation of how a service being developed. So now we name the steps. So basically, if we name the steps, so from the code to container, we call it, let's say, continuous integration, CI. And for the container to the production infrastructure or QA infrastructure, we call it continuous delivery, CD, right? So having named these steps, we now take a closer look at those steps. So let's say that in the CI step, what are we going to do? So basically, we need to check out the code version from a code hosting or collaboration tool, because we are many developers, right? So we are writing codes every day. So we need to have a kind of a platform where all the versions are being tracked. Then we need to check the code quality, because we are putting this code to production, so we cannot just put a crappy code, right? Then we must run all the tests, and we must see that it has a good code coverage, because that is also important, because otherwise we will end up in having bugs or system crashing in production. Then we need to build the container, and not only that, we need to scan the container, because containers can have security vulnerability, and for banks it's very important. Now we also need to save the container to a registry with possible version tracking, because we never know that we built a container and that fails, and then if we don't track the versions, we never know how to roll back. So these are kind of the fundamental steps that we do in CI. Now in the CD step, we basically take the published container and some user-defined parameters, and we package them. Then we create a deployable unit. Then we do the actual deployment. If it fails, we do the rollback to the previous deployment. Then we monitor the deployment, that if it actually does its job. And we also perform some end-to-end integration test, right? So now, if you see that, again, this bigger picture of digital automation, that we have several of these services, and if we want to do those CI and the CD steps manually, we will end up in a huge overhead, right? So how can we reduce this overhead? So let's take some kind of tools that can help us in automatizing those. So in the CI step, we can use, for example, Bitbucket to host the code. We can use Docker to build the container. Then we can use the PyTest to test our unit test and all those tests that we wrote. We use the Sonar Cube to actually understand that if the code quality is good. And we can actually, after we have the container, we can use the Prisma to scan for the security vulnerability. And we can use JFrog for storing that container. Now, of course, you can, I need to say that CI step and all these tools are highly depending on your tech stack. And trust me, there are like thousands of tools around. I just showed a very limited one just to keep the slide a bit cleaner. But of course, I think that many of you are already using these tools or probably some other tools. But here, just the idea is to show you some possible tools, right? So now in the CD step, here also, if you are in a Kubernetes kind of container orchestrator platform, then you can use Helm to package your container and the user-defined parameter to create a deployable unit. You can use Docker Swarm, Docker Compose, then Kubernetes to deploy, and then Splunk to actually monitor your service, also the ELK, and also WireMock to basically do the integration test. Now, combining this together, so CI become devs and CD become ops, and you can actually use a popular tools like Jenkins or Circle CI to combine all these intermediate CI/CD step tools to build your CI and CD step fully automatic, right? And thus, DevOps will help you to automatize your entire CI/CD step, and then if you remember the bigger picture, the huge overhead is just gone. So that's basically the advantage of AI, the DevOps in the digital automation in building the AI apps, right? So far, we have talked about a generic service and how the overheads are being reduced. Now let's talk about that particular area, the ML area, because that also contains services, right? So are they different? Are they any different than the generic one? Of course, yes, because you need to develop the model, right? And then you need to wrap an API around the model and put it to the production. So to get the jobs that like predictions or classifications that you want to do. So again, the same question we can raise that how difficult or how challenging is to manage those machine learning services, right? So in order to understand that, we need to understand the life cycle of such a service. And here I just mentioned the supervised machine learning model, basically. So, So in a supervised machine learning model, in order to build the model, you need historical data and the labels. So that is basically your data layer. And here, for example, if we want to build a document categorizer, so the historical data would be lots of documents and unknown labels. So those are the categories. Then you choose your machine learning algorithm and you perform a series of experiments to obtain optimum parameters that basically gives you an optimum model satisfying the business requirement machine learning KPIs, right? Once you have the machine learning model in your hand or in your computer, so you basically wrap that model in an API layer and put it to production so that it can do its job. So in this case, it can actually classify the unseen documents to a specific document category. So now we basically can see that machine learning service has this one step, which is the machine learning model development, which has data layer, model development layer, and the serving layer, right? So now we formalize it a bit more. So in a data pipeline or a data layer, what we should do, so we may do a lot of things, but probably these three fundamental things we must do. So one is that we ingest the data, and we need to do data versioning, right? Because otherwise we never know that, like the model that we are building, what is the underlying data behind? So we need to version the data. Second is we need to do some pipeline to clean the data and to validate the data, because often the ground truth data is not clean, so you need to clean it. And rather you need to validate it, basically. So you need to throw some kind of ground truth. And lastly, we should basically transform, after cleaning and validation, to a suitable data object to perform easy steps in the next steps, that is the machine learning model development step, some exploration and model fitting. So in the model development step, we can have these possible 4 fundamental kind of steps composed of, which is the data exploration or the feature analysis, then machine learning experiments tracking, and then optimal model identification through ML KPI, and finally the model saving with the version. And once you have, so now you can see that if we want to do all these steps again manually for this bigger picture, then again we are ending up in a huge overhead. So now let's take a look at the tools that can help us to do those things. So basically, in a data pipeline tool, we can use DVC, for example, to have the data versioning. We can have the Azure Machine Learning, Vertex AI, Google BigQuery, and also the data assets, and also the buckets, cloud storage buckets. So again, I mean, this is again a few examples, and it depends on the personal choice, the team's choice, the managerial decision depends on that. But trust me, here also we have thousands of different examples. And for the other part, for the machine learning development part, we have Kubeflow, TensorFlow, Scikit-learn, MLflow, Azure Machine Learning, again Vertex, and also the Jupyter Notebook, right? So now the point is that with all these tools, we can hugely reduce the overhead of the machine learning development part, right? So now once you have the machine learning model done, you need to put the serving layer, and there you can have the DevOps kind of paradigm to help that we explained before. And in this particular case, you can use NVIDIA Triton serving, TensorFlow serving, or also Vertex AI managed API. So now basically, if you combine the data, ML, and the DevOps together, you have the MLOps, and you can see that DevOps and MLOps are becoming key kind of pillars in which are helping us to developing the AI apps, thus actually implementing the digital automation as a vision, okay? So now we are kind of the end of the talk. So basically, for the DevOps, we can say that once the DevOps pipeline is in place, we can have a quick delivery time. So the solutions are kind of delivered quickly. We have improved efficiency and the performance. We quickly detect the bugs. And we also seamlessly do the software testing, releasing, and deployment. And also the rollbacks are kind of fewer because we are detecting the bugs and everything earlier. And also it is very customer-centric because it is kind of feature-oriented development, and also thus it's kind of reduce the cost. But at the same time, the DevOps can be a pain in the, DevOps can be very much problematic if you have underlying infrastructure and network slow, because it highly depends on the underlying infrastructure and the network. And also the internal configuration and update of this intermediate tool can lead to a build and deployment failure, because if your DevOps team does it something, next morning you see that your pipeline just fails and you take half a day to figure out what is the problem. So that's why you need to be careful. For the MLOps, we are basically achieving reproducibility, validation, and automation. Now how? So the reproducibility means that all our pipelines, the data pipeline, the machine learning experiment pipeline, these are all reproducible, right? And also those are all tracked because you are doing versioning, you are saving, and thus you are compliant with the AI regulations, because if the AI regulatory authority comes and say that show me the user consent and the model, you can readily kind of show them that this is happening. So nothing is hidden. The validation means that you are basically, it is coming from the DevOps, that you are introducing the software engineering best practices because you are basically following the CI/CD as well. So that's why you basically are knowing that your model are good, your API layers are good, and also you can basically do a model quality comparison offline. And also you can enable the explainability that we kind of saw in the previous talk. And for the automation, you basically also, it is coming from the DevOps that you can do a controlled rollback. So if your model is not working, you can go to the previous model, right? And also, you can get a kind of a feedback from the model drift, because it happens, like those here that use the machine learning apps, that you develop the apps today, then after 3 months, you see that the apps are not performing very well. So you need to know the drift. And as soon as you know the drift, you can kind of trigger your machine learning pipeline with the MLOps tools and the techniques that we have discussed to retrain the model and see that if it is working well again. And also, you are basically doing a continuous performance monitoring because also the logging and the monitoring is one of the part of the DevOps, right? So now, these are all good things, but what are the problems in the MLOps? So I highlighted one such problems that often happens that the business requirement is not just the repetitive models, that, okay, you have a lot of data after 6 months and you just click a button and you get a model and it's good. No, business often wants you to improve the performance, and improving the performance in a real scenario is a huge work because you need to do a lot of experiments. You may need to use newer algorithms, right? So this can create complex patterns in your data pipeline and also the ML model development pipeline, and you may need to redo everything. So that is why you need to take care of while developing the MLOps, because it's not like kind of a piece of cake that you just baked it and eat it forever. It's not like that. So you need to improve that recipe of the cake. So that is all, I think. So I think that's is the end of my talk. And so, Ivan, please. Thank you very much.
Okay, thanks for this actually great overview about all of the steps to actually, yes, a lot of things that you have described with a lot of details. And actually is now the moment of our Q&A. I ask to Ilaria to join us again here on the stage, and I see that there's already some questions. Then I guess that if you all have already taken notes about the Slido, we can now, go on start with the first question, that is, what were the improvements once you set up the MLOps infrastructure? How does the business receive this kind of impact? I guess this is for you.
Yeah,
for sure.
So let me read the question. What are the improvements once you set up the... okay. So as I mentioned in my concluding slide, that the improvements are basically with the MLOps, we basically create the reproducible pipelines, right? And also, we version the data, we version the model, so everything is kind of tracked. And thus, we are compliant with the AI regulations. So those are one thing. The second thing is that the validation, because when we are setting up the MLOps, then we are having the CI/CD pipeline done, so we also can compare the result. We also can test our models offline, those kind of thing. And also for the automation side, we can also basically control rollback is possible. And also that particular part that I said, that the model drift, understanding the model drift and retraining the pipeline again, so that we basically make happy the business forever, kind of the dream. So that's basically the improvement. And the business impact is, it would be the thing that the cost reduction for the business point of view, and the fewer errors, and also I would say the reliability, accuracy, and the faster execution time for those digital automation process. So those internal workflows would be much more faster. I think that is all.
Okay, thanks. And the next one is for Ilaria. How do you decide if an explainable model can replace a black box, even if give less precise predictions?
Where is it? Okay, the point is that it depends. So you don't want to replace the black box, because very often a black box is a method that is so much more complex that is able to perform a better job. So basically, you don't want to get rid of the black boxes, but still you want to be able to shed some light on those. So the idea is to be able to explain, at least in part, their behavior. Then it's all a trade-off. Obviously, it depends, I would say, on the application, on the complexity of the problem that you are considering. And there can be cases where a simpler model that maybe is easy to interpret can work well enough. I would say that it must be a trade-off between the performance, the predictive performance, and the needed right to explain.
Okay, there's we are back on the topics of MLOps, DevOps in this case. Then, what is the best approach to design MLOps DevOps infrastructure, top-down or bottom-up? There's also the example, top-down from overall pipeline or bottom-up tools and system in place.
Okay, good question. So I'm not sure if I understood the concept of top-down, bottom-up. So, okay, so the point here is that since we are talking about MLOps first, so as a developer, you talk to the business, right? So you get a business requirement. Then readily, some of the, like the brilliant guys, data scientists, they will come up with a design, right? That, okay, we take the data, we do this and that, and we get this magic kind of thing. And then that magic comes to the ML engineers who wants to put it to the production, right? So now you need to fix certain tools, because the point is that for MLOps, it can happen that it can readily go out of your hand if you kind of try to. So what I'm saying is that if you want to work in GCP, you have to stick to GCP. If you want to work in Azure, you need to stick to Azure. Of course, you can mix, but I mean, the mixing takes time. So you need to first set up one kind of paradigm, and then you go to the next. Like, so if you just readily set up both the things at the same time, things would go messy. So what I'm saying is more like best approach would be that you first understand your team's capability, team's knowledge, that maybe your team knows better the Azure machine learning, or maybe Vertex AI, or maybe something SageMaker, I don't know. So you develop the MLOps around that knowledge, right? So that should be, and then you train your people, and then you see that, oh, that cloud provider is giving me better options, so let's move on to there. So I would say that's the best approach. Although probably it's a big thing to say what is the best approach, right? So for me in this way, top down, bottom up. As I said, like you learn the business requirement and you know your knowledge base, and based on that you design. I mean, that's what I say.
Okay, thanks. And actually, we have a next question that is. Does the requirement of explainability represent a limit for your work?
Well, rather than a limit, it's something that we have to face. Certainly, it requires, novel work, because looking into explainability of our models is something that we have started to do, let's say, more recently. Without that requirement, you can just stay with a very efficient black box, and that's it. But explaining the models is becoming more and more necessary, and not only because there are legal requirements on this. There is an upcoming legislation that is asking, to support the capability of explaining the machine learning, the outcome of machine learning models. But also, this is, as I said before, is really needed to be able to foster a widespread adoption of these methods. If we are not able to explain why they behave in a certain way, then it may be the case that people would not trust them and would not use them in the end. So this is needed, and well, rather than a limit, I would say it's an opportunity to do a better work.
No, well, that's actually true. I mean, that transforming a limit into a strength in this case. Then, well, great talks. Thank you. Question about MLOps. How do you balance between experiment models update and model retirement? What are the main criteria that make a difference?
Very, very good question. So actually, I would say that since we are in an industry, so all these are set by the business and the budget. So we are not a research kind of companies, right? So having said that, very good question. So it's actually very tough to answer as well. So I mean, the business often says that I want something and that is impossible to achieve. So you negotiate. How? So you get the data and you do certain kind of feasibility study, we say, like a kind of a 1 month or 2 month spike. And then you say to business that, look, we have this. Now, then you negotiate that, okay, we ship it, and then you use it, And then we will do next phase to improve that. So often it is like 2 to 3 months that you need to give something. Either you give a good model that business understands, or you say, I can't do it, something like that. Because also in an industry, before you do, sometimes you also do the scouting, right? So you know that what are the available kind of solutions, and then if you can buy them, and if the cost is very high, then you do in-house. So there are a lot of this going on as well. So I would say, I don't know if I answered this question, but somehow.
No, that was a good attempt in that direction.
But good question.
And well, I see actually, okay, well, explainable AI. How can, there's a lot of text here, I mean, how can we avoid the risk of that not expert users exposed to counterfactual explanations may interpret them as a causal explanations and expect to necessarily obtain a real change by intervening according to the counterfactual explanations?
Okay, there are a couple of things maybe that we can say about this. First of all, as the counterfactual explanations that you have seen today were very complex, were very simple, not complex. So just to give you a flavor of the idea. But for counterfactual explanations to be actually used in real use case, for sure, we must work on them and make sure that they satisfy a lot of these properties that I was saying that are needed to guarantee that they are actually good, like for example properly taking into account the causal relations among features. So this for sure, okay? So it is a lot more complex than what you have seen today. Then I would also say that okay, there are probably various levels at which these counterfactual explanations can be used. The first use that I foresee is rather than giving them directly to an end user and an expert one, probably I would use them to support, let's say, the work of expert that maybe act as an interface towards these non-expert users, maybe deriving the correct insights to suggest maybe good actions without giving wrong beliefs about the causality of what you are suggesting, if that is not guaranteed.
Okay, then actually we have sort of a good alternance about the two topics. Then we have in Unicredit CI/CD workflow, what are the duties of the data scientists and what are the tools, tasks of the data machine learning engineers?
Okay, good. So actually the duties of our data science is just to produce very good models, right? No, jokes apart. So the point is like, the point is that once we means the data engineer, machine learning engineers kind of come up with a kind of a technology and set up the ML ops, the role of the data scientist would be to quickly adapt to it and to use it as much as possible to do these reproducible pipelines, right? Maybe sometime it may not be possible due to complexity, due to legacy code, etc. But that's the fundamental duty. And for the data engineer, ML engineer's duty is to maintain this pipeline as stable as possible, I would say, and then look for expanding it to the other vendors. So that's the hardest part, because basically, if you keep one MLOps for a longer time, you often see complex patterns and everything. So the data engineer should basically, the duty is that we need to understand how to simplify the things and go back to the data scientist to train them, not to train them, I mean to tell them to utilize this pipeline, because that is going to help us in long run. That is it.
Okay, actually, thanks. And I mean, since there's still some questions, but I guess that the time is over. I just read the one question that is something more similar to, I don't know, a science fiction, a real question that is, why augment humans rather than replace. Is AI lacking necessary capabilities available only on human side? I mean, this is actually yes, but I guess that we all,
The thing is that as inhabitants of planet Earth, we want, AI to make our lives better. So that is the point, and in order to do that, we need to make sure that these systems behave properly so that, we can put the right level of trust on those.
Yes, and that's, more generically, the point that human beings are still human beings. I mean, there's still some things that a machine cannot actually reach. And, actually, given that, thanks you all for being here with us and the ones that are connected. Of course, if you have missed something, you can see the registration of this event as well as the previous meetups event as Paolo described before, and also the ones that we hosted last year. I hope that you all enjoyed this event, and see you at the next time.